And yet another example with powers of x inside radicals. Based on the previous example, we know how to handle that now. So what we're going to do is we're going to convert all of our radicals to fractional powers first, and then we're going to multiply the powers on x times those fractions. To illustrate, we have this 5, that's just going to stick around, but the radical is going to turn into x squared, because that's on the inside, to the 1/3 power. Then you have minus 3.2 times x to the 5th to the 1/2. Okay? But hey, this last term is very convenient because there's no radical on it. We don't have to do anything weird with that. It just comes along for the ride. It's just x squared. No need to convert it. Don't let that confuse you at all by the nature of the problem. Okay, now let's see if we can simplify this algebraically a little bit. The 5, the coefficient in front of this, is just going to come along for the ride. It doesn't impact the exponent at all. So now, how do we handle an exponent of an exponent, where you have x squared to the 1/3 power? Exponent rules tell you that that's the same thing as x to the 2 times 1/3 power. We're going to do the same thing in the second term here, 3.2 times x to the 5 times 1/2 power, and then nothing changes with this x squared, because it's already simplified as much as it gets. All right, so simplifying these fractional powers, we have 5x to the 2/3 power minus 3.2 x to the 5/2 power plus x squared. So now that each of our x's have a single power on them, no other weird things going on with the fractions and the exponents, we can now hit it with the power rule. So what we're going to do is we're going to take our powers, bring them down, multiply them by whatever's out in front, and then subtract 1 from the exponent, just as what we've done in the last 38,000 examples. So we have 5 times 2/3 x, okay, then you have 2/3 minus 1, so that gives you minus 1/3. Then you have minus 3.2 times, okay, we're going to bring this exponent down in front and multiply that. So you have 5/2. And then you have x, and we're subtracting 1 from 5/2 in the exponent here. So what does that give you? So it should give you 3/2, because you subtracted away 2/2 if you want to convert that minus 1 into 2/2. Okay, so that's that. And then we derive this final x squared. You're going to see this x squared a lot throughout your entire calculus education, and you're going to get very, very comfortable with deriving it. It's just 2x. Okay, same exact strategy we used before to derive that x squared. All right, so now we need to simplify a little bit. How do we multiply this 5 times 2/3? Well, you can just multiply straight across the numerator and denominator. So this gives you 10/3 x to the minus 1/3 minus, okay, so now we need to multiply 3.2 times 5 divided by 2. So what does that give us? Turns out the answer is 8. Okay, and you have x to the 3/2 power, because nothing changes there, and then you have 2 times x in your final answer. So hopefully that all works out for you. And that is the final answer. That's it. Nothing more to do. Could convert this to could convert your fractional powers to radicals. Don't worry about it. You've done exactly what this problem asked you to do, which was find the derivative of the original nasty radical function.